In this video here, we're going to take a look at flowcharts. Now, within this chapter here, the algorithms that we're working with may be given in the form of a flowchart. And this is just another way to present the instructions and steps of an algorithm. So nothing challenging here, just basically a direct continuation from the previous video where we introduced algorithms. Now, in a flowchart, the shape of each box tells you about its function. So there's three shapes here, or three boxes that you need to recognize. So let's just quickly run through each one here. So for the first shape here, this just tells us then whether we're at the start or the end of the algorithm. Nice and easy, right? For the next shape here, this just gives us an instruction. And then finally, for the very last shape here, this just gives us a decision. Now, as you work through a question on flowcharts, clearly you can tell, based on the shape here, whether you've got an instruction or a decision, right? That's quite intuitive and obvious. So you don't really need to learn by heart here, each one of these shapes. It should just be obvious as we work through a flowchart. But just so you're aware here, then each box here tells you about its function. It will be the same then for every single flowchart. Now, the boxes in a flowchart are linked by arrowed lines. And as we saw in the previous video with written algorithms, we do need to follow each step in order, right? That's the whole point of an algorithm. And before we work through the practice question for this video here, just make sure then that you've watched the previous video where we introduced the concept of algorithms. So with all that in mind then, let's just work through a practice question together here on flowcharts. So let's just have a go then at this one practice question here for flowcharts. Now, as we can see, then we've got this flowchart here, which can be used to find the roots of an equation of this form here. So in other words, just a quadratic equation, right? And all we want to do here for this question is just implement this algorithm for the following equation. So as we can see, then we've got part A, part B, and then finally to finish with here, part C. What we've also given you for this question here is the respective trace tables for each part of the question, right? And the same would be true here for an exam question based on flowcharts and algorithms here. If you do need a trace table, you will be given the trace table in the question. So not something that you do need to worry about. Right, so let's just get started here then with part A. So for part A, then what I've got here is this quadratic equation. So I've got 3x squared minus 2x plus 5 is equal to 0. So starting off here then, this trace table here is for part A. This one here is for part B. And this one here is for part C, right? But let's just go back to part A for now. So to get us started here, we input A, B, and C. So along the top row here, we have A, we then have B, and then finally we have C. Okay. So what is A, B, and C here? So A is 3, B is minus 2, and C is 5. Okay. That step is complete. So we now just go down here, just follow the arrows as we go, right? We need to go in order here. We just continue down. Now for the next step here, we now just let D be equal to B squared minus 4AC. So D here, as we just said then, is equal to B squared minus 4AC. So B squared is 4 minus 4 times 3 times 5. So that's minus 60. So 4 minus 60, that gives us minus 56. Perfect. We then continue down here. We've now got a diamond here, so we have to make a decision, right? The question here then is D strictly less than 0. So hopefully that is obvious, right? We are studying further maths. I'm hoping that is obvious to all of you. And the answer to that is clearly yes, right? Minus 56 is clearly strictly less than 0. So I've got the question here. Is D strictly less than 0? Like we just said then, the answer to that is yes. So in that case then, we print no real roots. So I'll print that here. So no real roots. And at this point here, we just, follow the arrow, right? So follow the arrow down, follow the arrow to the left. We arrive at this arrow here, we go down, and the algorithm terminates, right? Stop. In that case then, part A is complete. Hopefully, nice and easy. So now for part B then, what I've got here is this quadratic equation here. And applying the algorithm to this quadratic equation here is almost identical. So again, we start off here. we go down and we input A, B, and C. I've got A, B, and C here. So A is 1, B is 8, and then finally C here is 16. Okay. We then go down here, so we let D be equal to B squared minus 4AC. So D here is equal to, so B squared is 64 minus 4 times 1 times 16. So that's 64 minus 64, which is 0. We then go down here. Again, we've got a diamond here, so we have a decision to make. So is D strictly less than 0? So just be very, very careful here, right? D, in this case here, is not strictly less than 0 because D is equal to 0. So D here is strictly less than 0. The answer to that is no. Okay. I forgot it here, but there should be a no there, so apologies for that. So the answer is no. So we go down. Again, we've got another diamond here, and in that case, then another decision to make. So is D equal to 0? So is D equal to 0? And again, it should be obvious, right? The answer to that is clearly yes. So D is equal to 0, so I put yes there, like so. In that case, then we go to the right here, and I let x be equal to minus b over 2a. So x here is equal to minus b over 2a. So that's minus 8 over 2, giving us minus 4 there. Okay. I then print equal roots are x. So equal roots are x, where x here is minus 4. So equal roots are minus 4. I then follow this arrow here, follow the arrow down to the left, down again here, and we stop. And that tells us then that the answer to part B here is simply as follows, and the algorithm then is complete here for part B. And then finally, for the very last part of this question here, we have part C. So for part C, then we've got 4x squared minus 4x minus 15 is equal to 0. And again, the method I'm working here is almost identical to part A and part B, right? So again, we start off here, we go down and we input A, B, and C here. So A, B, and C here. So A is 4, B is minus 4, and C is minus 15. Okay? So D here. So if I just go down then, D here is B squared minus 4AC. As you can see, I'm kind of just going through this naturally now because I've already done it 2 times already, so it becomes quite intuitive. You get the idea. So D here is B squared minus 4AC. So what would that be here? I will use a calculator just to ensure that I don't make a mistake. I get 16 minus 4 times 4 times minus 15. And I get 256. So 256 there. So we go down here, we've got a decision to make. Is D strictly less than 0? Well, clearly no. So D less than 0. The answer to that is no. We go down, another diamond here, another decision to make. Is D equal to 0? Well, again, clearly no. So D equal to 0, again, we just put no there. We continue down here. So in that case, then I let x1 be equal to minus b minus the square root of d all over 2a. So I've got x1 here. Then we would have x2. So for x1, then this is minus b. That's going to be 4 minus the square root of 256. And then we divide that by 2a here. So 2 lots of 4, which is 8. So I get minus 1.5 there. So minus 1.5 for x1. And then for x2 here, it's minus b plus the square root of d all over 2a. So I get 4 plus the square root of 256 all over 2a. So that's 8. What I get there then is 2.5. We get 2.5 there. Perfect. So what I now do here, we go down and I print roots at x1 and x2. Obviously, just replace x1 and x2 with your respective values here. Hopefully, you get the exact same, but you get the idea. So, roots are x1, which is minus 1.5, and 2.5. Okay, perfect. And then we've completed that step here. We go down and we stop, right? The algorithm is complete. So perfect, right? For part A, we had no real roots. Part B, we had equal roots and minus 4. And then finally for part C here, the roots are minus 1.5 and 2.5 there. Tick. Perfect. Good stuff. And there we have it then. So as you can see, implementing an algorithm here using a flowchart is pretty straightforward. If anything, it can be a little bit tedious. These examples here are quite short. Sometimes you might see some quite lengthy examples, but generally speaking, under exam and time conditions, it will give you something reasonable. But yeah, there we have it, right? So I'm kind of just waffling now, but you get the idea. So there we have it then. That gives the solution to the one practice question for this video here. And that brings us to the end then of this video here on flowcharts.